In the movie Mission Impossible Ghost Protocol, Ethan Hunt needs to go to a floor higher than he is, but he can't use the lift, so he decides to choose the next best option. Now he's proved in his mind that the only thing that he can do is crawl on the side of the building. Now, I want to talk a little bit more on this notion of proving things, but in a more formal context. This video is going to be about mathematical proofs, but before I get into it, I want to talk a little bit about how mathematics is structured and how that may be different from the other sciences. So to do this, let's do a little exercise. Think of any scientific concept and keep asking yourself questions about it. Say, I wanted to know what the tip of this pencil was made of. Science may say that the tip is made of graphite. Zoom in a little more, and there would be molecules. A little further, and there would be electrons. Eventually, we'd reach some questions that there are no answers to yet. It's different from math, however, since as you keep asking yourself questions, you may notice that the concept actually gets clearer each time. Eventually, you'd reach some of the most basic truths of math, and these are called axioms. And that's where proofs come in. Again, a proof is just an argument, similar to one that you'd use in a courtroom, except here, there's no reasonable doubt. And the same way that there's different ways of doing scientific experiments, there's different methods of proof. And I'm going to look at two in this video, each with a problem. The first one we'll be looking at is proof by contradiction. Say we wanted to prove that the number of primes is infinite. We would start by assuming the opposite of this, which is that the number of primes is finite. Now this implies that there's some set of primes that ends at n, which is very much finite. We can make a variable capital N that's the product of all of these primes, and another variable q, which is this product plus 1. If q is prime, then we've already found a prime that's outside our original set. If it isn't, then there's some factor that divides both n and q perfectly. But since the smallest prime is 2, this is not possible. These two facts make our conjecture a theorem. So we can use this same process for another method of proof called induction. Let's say you had a chef that wanted to find out, for a certain number of cuts on a pizza, what's the maximum number of slices you could get? Let's find out. The first step is to test the conjecture on the left with small values such as n is 0 and n is 1, showing that this is true. The next step is called the inductive hypothesis, where we say if the conjecture is true for n is k, it must be true for n is k plus 1. A good way to visualize this is with multiple dominoes, where each one represents k, k plus 1, and so on. If one was toppled, then we've proved the theorem. So now, we can write the conjecture as a function where if f of n plus 1 is equal to f of n plus 1, we've proved it. Now, simplification of both sides leads to the same term, so we can topple the first domino, proving our theorem. So I hope you learned something about proofs, not just in math, but as a way of thinking.